Hi all, in today's video we're going to be looking at simplifying surds. Okay, so what a surd is, a surd is a special kind of irrational number. Okay, and what that means is it's a square root, cube root, could be the fourth root, etc, etc. But when we do that, it does not have an exact answer. Okay, so if you look at the examples just below, you can see that if we'd done the square root of 9, we would get 3, if we'd done the square root of 100, we would get 10, and if we'd done the cubed root of 64, we would get 4, okay? And if you put them in your calculator, you can check, those are the answers there, okay? Now, those are examples of not being surds, okay? They are not surds because they have an exact answer, okay? There's no need to round our final answer here, okay? However, if you look below at, for example, root 15, the square root of 15, or square root of 87, or even the cubed root of 53, we would see we would get a decimal answer, okay? So they are surds, okay? If we put them in a calculator, we would have to have rounding to get right on our answer on a bit of paper, okay? They are not surds, okay? They don't have an exact whole number answer. Okay, so that's what surds are. What we want to do though is if we're given a surd, how can we look to simplify it? Okay, so if you look below, okay, we're going to look at answering these 4 questions in our notes. Okay, so it's 10.1 section A. So, okay, we discussed that a surd is a root which does not have an exact answer. Okay, in order to simplify a surd, what we do is we need to write it as a product of 2 numbers. Okay, however, one of the numbers needs to be a squared number. Okay, and the squared numbers, okay, if you write them down, they're on top of our notes there, and they've actually missed out the value 1 there. 1 is also a squared number, but 1 won't change our question for any matter. Okay, so that's why we don't really think about 1 at this point. However, we're going to use 4, 9, 16, 25, and so on, okay, and that's going to be the numbers we're going to use to help simplify these surds. Okay, so going forward, okay, let's look to see how I could simplify each of these. Okay, so starting off with the first question, okay, we have got to try and simplify root 72. Okay, so what I do is I look at all my squared numbers here, okay, and I try and work out which one that I'm going to use could help me with simplifying 72. Okay, I want to find a number that I've highlighted there that I can use to divide into 72, so I can write it as a product of 2 numbers. Okay, now this is an example where there's actually many possible answers. Now, in order to find the answer the quickest way, we always want to find the biggest number we can use here. Okay, so for example, I can split 72 using 4. Okay, because 4 times 18 would give us 72. That would work. Okay, 4 is a squared number, that could work. I could also do 9 times 8, that would give me 72 as well. Okay, I can't use 16, okay, 72 does not divide by 16 at all, okay, and get a whole number out of it, so we're not going to use that. But 36 does, okay, I can use 36 times 2 to simplify root 72. Okay, so I've got a few options, but I want to pick the biggest one, so I'm going to use 36. That's the biggest square number that will work here. Okay, so how do we deal with this? Okay, we set up our question, so we do root 72. Now I'm just going to change my pen colour here. So we're going to do root 72. Now it's very important that you show all your work in here. Okay, so what we're going to do is we're going to split that up as in 36 times 2. Okay, and I've used 36 because that is one of my squared numbers. Okay, and it's the biggest one that I could use here. Okay, then what we do is we split these two up. Okay, so that's going to be root 36 times root 2. And why we use that? Well, root 36, that is not a surd. I can change that to a whole number because 6 times 6 will give me 36. So the square root of 36 is indeed 6. And I've got to times that by root 2. And my final answer would be 6 lots of root 2. Okay, so that's me simplified that root there. Okay, we'll now jump to root 80 again. So again, I've got choices here. I know 80 is in the 4 times table. Okay, I can also divide it by 16. Okay, that's going to help me out a lot because 80 divided by 16 would give me 5. Okay, it doesn't fit into 25. Sorry, 25 doesn't fit into 80, nor does 36, nor does 49, or any of the others. So the biggest one I can use is 16 here. Okay, so again, similar process. Root 80 will be, we're going to use 16, so it's going to be 16 times 5. Okay, that's going to split up, so we do root 16 times root 5. Square root of 16 is 4, that's going to be 4 times root 5. and that would give me 4 root 5 there. Okay, so that's my answer for that there. Okay, we use 16 to split the root 80. Okay, right, we'll do this ones a bit quicker now. Hopefully we've got the idea. So again, root 200, I'm looking for two numbers, but one of them being a squared number. Okay, and we're going to use 100 here. Okay, so I can split that into 100 times 2. That'd be the biggest square number I could use. Then it's going to be root 100 times the square root of 2. Root of 100 is 10, so that's 10 times root 2, and that's going to give me 10 lots of root 2 there. Okay, now we'll move on to root 99. Okay, so the biggest square number I could use that divides into 99 is 9. That's going to be root 9 times 11. Okay, split them both up. That's going to be root 9 times root 11. Root 9 is 3, so that's 3 times root 11. That gives me 3 root 11. Okay, so simplifying surds is how we deal with a process like that. Okay, but let's look at the next lot of questions in our notes. We're going to go down to 10.1 part C. Okay, we're going to miss out part B. Okay, we don't need to do that. So we can add and subtract surds when we get surds equal to each other. Okay, so for example, we want to simplify these to get our answer. Okay, however, what I must do is I must look at the surds I've been given, and I need to write them in a way that the number that stays in the square root becomes the same as that's in the same question. Therefore, I can combine my answers. Okay, and it's probably easier to see how a question works first before you really understand this process. Okay, so what we do is we just look at this first question, and my job here is I'm going to simplify both of these. Okay, because they can both be simplified. So root 50. Okay, that could become root 25 times 2. That can be square root of 25 times root 2. That gives me 5 times root 2. That gives me 5 lots of root 2. Okay, so root 50 can become 5 root 2. Now let's look at root 32. Okay, so I can split that up. Okay, that becomes 16 times 2. That becomes square root of 16 times the square root of 2. That gives me 4 times root 2, which gives me 4 root 2. So what the answer to this question will look like, okay, rather than doing root 50 take away root 32, which is what I've got, it's going to be my answer for root 50, which is 5 root 2, take away the answer to root 32, which is 4 root 2. And I can now combine these because I've got the same number in the square root. I've both got root 2's here. Okay, so if I've got 5 lots of root 2 taking away 4 lots of root 2, okay, 5 take away 4 is 1. I'd have 1 lot of root 2, which is just root 2. Okay, so that's what we mean by adding or subtracting roots. Okay, we need to simplify them first in order to add or subtract them. Okay, we'll look at the next couple examples as well. Okay, so this one here, I've got 2 lots of root 45 plus root 80. Okay, so again, my numbers in the square root are not equal to each other. I can't combine these just yet. What I'm going to do is I'm going to simplify the square roots. Okay, so the surds. So root 45, okay, that can be split up as in 9 times 5, which would give me the square root of 9 times the square root of 5, which is 3 times the square root of 5, which is 3 root 5. Okay, so my answer for root 45 is 3 root 5. And I need to do square root of 80. Now, we actually did the square root of 80 in section 10.1 part A. So I'm not going to go through the working like I did at the top. I'm just going to show you that my answer will be 4 root 5. Okay, that's what we got as my final answer there. So I'm just going to jump forward with that. Okay, so what this question was it was 2 lots of root 45 plus the answer to root 80. Okay, now I'm just going to draw this line here so that I'm not interfering with the work from the left hand side. So 2 lots of root 45, well my answer for root 45 was 3 root 5, so that's going to be 2 lots of 3 root 5. Okay, plus the answer to root 80, which was 4 root 5. 2 lots of 3 root 5 times the 2 with the 3. 2 times 3 is 6. That's going to be 6 root 5 plus 4 root 5. And my final answer, if I add them, 6 plus 4 would give me 10. So I'm going to have 10 lots of root 5 there. Okay, and that'd be my final answer for the second example there. Okay, so we had a bit of work to do with the simplifying part, and then we just have to substitute it back into my question, and we can do that because we both had 5 in our square roots, we can then combine them. Okay, look at the last one. Okay, first thing to note is that these are all different numbers in the surds. However, there's actually a surd I cannot simplify, and the one that I cannot simplify is this one here. Okay, root 7. Okay, the only numbers I can use to multiply together to give me 7 is 7 and 1, and neither of them are squared numbers. Well, 1 is, but the square root of 1 is just 1, so it doesn't change my question, so there's nothing I can do with that one there. Okay, so what I'm going to do is I'm going to try and simplify the other two. Okay, and what I'm hoping is that root 7 can come out, therefore I can combine that root 7 with one of the other two, or maybe both of them. Okay, that is what I'm hoping to happen at this stage. So root 7 is the key here in order for me to combine all these. Okay, so if I then think of root 63, that would be the square root. Okay, well, 9 times 7 would give me 63. That'd be the square root of 9 times the square root of 7. Good, I've got square root of 7 here, that's looking hopeful. Square root of 9 is 3, so that's 3 times root 7. And that would be 3 root 7. Okay, good, that means I'll be able to combine the root 63 with the positive root 7. Now let's go to the root 28. Okay, so root 28, that's going to be the square root of 4 times 7, that gives me 28. That would be square root of 4 times the square root of 7. Square root of 4 is 2, so that's 2 times the square root of 7. That equals 2 root 7. Okay, which is good, and therefore it looks like I'll be able to combine all these here. Okay, so my question, okay, it was root 63, take away root 28 plus root 7. The answer to root 63, the answer was 3 root 7, so that's going to be 3 root 7. The answer to 28 was 2 root 7, so it's going to take away 2 root 7 plus a root 7. Okay, so how many root 7s will I have? Well, 3 lots, take away 2 lots, will leave me with 1 lot, plus another lot there. That will be 2 root 7. Okay, so there's a video on simplifying surds just when they give you one surd to simplify, and then also how it can be used when you have multiple surds in your question. We have to add or subtract them together, but we can only do that once we simplify them all and hopefully get the same number in our root. Okay, so we're left with the same surd so we can combine them. Okay, thanks for watching.